Hello there, and welcome to Fall Asleep to Science channel. Tonight we drift into one of the quietest questions ever asked, a question older than time itself. What existed before the Big Bang? It sounds simple, like a riddle whispered into the dark. Yet behind those few words lies the edge of all knowing, the point where physics, philosophy, and imagination blur into silence. Before the first stars, before matter, before even the ticking of cosmic time, there was supposedly nothing. But what does nothing mean? Not the space between planets, not the dark gaps between galaxies. Those are full of fields of radiation, of structure unseen. We mean something deeper, a kind of absence beyond being. No matter, no space, no rules to hold or describe them. Just a stillness so complete it resists even the word is. And yet, from that stillness the universe blooms. Light unfurls from density, space stretches, time begins to move. Energy cools and condenses, and in that slow unfolding, we arrive. Atoms, stars, eyes, thoughts, all born from a question that has no obvious answer. Tonight we explore that question gently. We move through philosophy, where thinkers wrestled with the very meaning of nothing. Through physics, where experiments revealed that even the emptiest vacuum hums with life. And through cosmology, where the Big Bang itself may not have been a beginning, but a transformation. Each idea is a ripple in the dark, a glimmer across the void. Together, they bring us closer, not to certainty, but to awe. If you enjoy these quiet explorations, a soft tap on the like or subscribe button helps other sleepy minds find their way here too. One gentle soul at a time. And tell me softly, where in the world are you listening from tonight? A city glowing under clouds, a quiet countryside beneath the Milky Way, or somewhere in between? I love imagining each small point of calm lighting up across the planet as we drift together. So let your breathing slow. Imagine the night as a vast horizon of time, and let your thoughts drift toward that impossible moment before the first moment. The question of what came before the beginning has always lingered like a quiet echo in the human mind. Even before science, before telescopes and equations, there was curiosity, the simple wonder of how something could rise from nothing. The thought itself feels circular, almost paradoxical. And yet, like a distant pulse, it continues softly, persistently, inviting us to look inward as much as outward. In the ancient world, this question was not only cosmic, but spiritual. To ask what is nothing was to ask, what are we? Every philosopher, in their own way, met that silence and tried to give it shape. Aristotle could not accept the idea of a true void. To him, the universe abhorred emptiness. He imagined the heavens filled with ether, a divine substance more perfect than air or fire. Space, in his view, could never be bare. Motion required a medium, and everything from the turning of the stars to the fall of a leaf depended on a continuum of being. For Aristotle, nothingness was a contradiction. To exist as nothing was impossible because even the idea of a void must exist somewhere. It could be imagined, but never realized. The cosmos, therefore, was eternal and self-contained, full-layered, unbroken. There's a strange comfort in that idea. A universe that leaves no gaps, a reality that hums with constant fullness even in its quietest corners. It echoes the way the night sky feels when you look long enough, not empty, but alive with unseen motion. But others disagreed. Across the Aegean, thinkers like Leucippus and Democritus looked at the same stars and imagined something different. They believed that everything from stone to starlight was made of indivisible particles, atoms, drifting through an infinite void. To them, the void was not absence, but space for motion. It was the breath of reality, the silent stage upon which atoms danced. Without emptiness, they said, nothing could move, nothing could change. The void was necessary, not terrifying. It was the universe's way of allowing freedom. How strange, then, that emptiness, so often feared, became a requirement for creation. Even the ancient Greeks could sense that nothingness might not be nothing at all. It might be a kind of permission, a background silence that allows the song to begin. Centuries later, in the dim candlelight of medieval Europe, the question turned theological. If the world was made what existed before the act of creation, theologians spoke of creatio ex nihilo, creation from nothing. God, they said, brought the universe into being not from matter, but from pure will. Nothing here became holy, not emptiness, but divine potential. Awaiting stillness before the first word, let there be. In this view, nothing was neither void nor chaos. It was the sacred pause before existence, a breath held in infinite patience. When released, it became light motion and the unfolding of time. This idea softened the harshness of non-being. It gave purpose to the absence, as if the universe had always been meant to arrive, as if silence itself desired to speak. Then came the philosopher Gottfried Wilhelm Leibniz, who in the 17th century distilled the entire debate into one quiet sentence. Why is there something rather than nothing? It is a question so direct, so haunting, that it still stands as one of philosophy's great anchors. Why should existence exist at all? Why not the infinite simplicity of nothing? Leibniz believed that something must exist because existence was the more perfect state. That a universe, even a vast and complex one, was more natural than the absence of all possibility. For him, reality was not random. It was the necessary expression of an underlying principle. Perhaps God, perhaps logic itself, that favored being over non-being. And yet, that logic remains incomplete. Because if something must exist, we are left to ask why this something. Why stars and atoms and minds capable of asking? The question expands like space itself endlessly. In the 20th century, nothingness returned not to the stars, but to the self. Philosophers like Sartre and Heidegger looked inward and found their own kind of void. For them, nothing was not about the universe's beginning, but about the absence of inherent meaning within it. If existence precedes essence, then the universe offers no predefined purpose. Meaning is not given, it is made. Sartre wrote that consciousness itself is a kind of nothing, an awareness that exists only by perceiving what it is not. To be human, he said, is to live within a space of potential, to create purpose from the silence around us. Heidegger went further, suggesting that only by confronting the nothing, by facing mortality, uncertainty, and the abyss, can we truly encounter being. In their writings, the word nothing becomes strangely luminous. It's not despair, but recognition. A gentle acceptance that our awareness, fragile and temporary, glows precisely because the dark exists around it. As philosophy evolved, one theme returned again and again: the idea that absolute nothingness is impossible to conceive. Try to imagine it. No space, no light, no memory, no observer. The moment you do, the act of imagining creates a frame, a kind of something within which the nothing must appear. It collapses under its own paradox. This is where thought reaches its limit, where logic begins to dissolve. To think of nothing is to think of being without being. And that's a thought that cannot fully form. And yet, this is precisely what makes it fascinating. It's like staring into a mirror that reflects not your face, but the absence of all reflection. The mind strains to see what cannot be seen, and in doing so becomes aware of its own boundaries. Gradually, philosophers began to see nothing not as negation, but as possibility. The absence that allows presence to arise. The pause before a wave. The stillness from which a thought, a star, a universe might unfold. This subtle shift changed everything. It turned the void into a kind of creative background, not hostile, but fertile. As if the most fundamental truth of reality was not being or non-being, but the delicate rhythm between the two. You can feel this rhythm in nature. The way silence gives meaning to sound. The way darkness defines light. The way stillness between breaths sustains the act of breathing itself. Every something seems to lean gently against its own absence. So perhaps nothing is not the opposite of existence but its mirror, not a denial but a necessary complement. These ideas of fullness and void, of creation and absence, did not stay confined to philosophy. They became seeds for science. When physicists began to ask what space was made of, they were unknowingly tracing the same ancient steps. From Aristotle's fullness to Democritus's void, the lineage of nothing continued, passed from thinkers to alchemists, from metaphysicians to mathematicians, until it reached the age of experiment. And there, something remarkable happened. The void once thought empty revealed itself to be alive. In laboratories and equations, nothing began to shimmer, filled with subtle forces, flickering energies, and invisible patterns. It turned out that the silence of space hums quietly with potential. But before we drift toward that scientific horizon, pause here a moment. Imagine the night sky again, wide and unbroken. Its darkness is not absence, but depth. Even where you see nothing, light travels unseen. Even where your eyes find emptiness, the universe whispers softly through the quantum sea. The philosophers reached toward this truth through thought. The scientists through measurement. Both followed the same current, a longing to understand how everything can rise from what seems like nothing. And as the story unfolds, we begin to see that the boundary between nothing and something is not a wall but a gradual dawn. Philosophy brought us to the edge of thought, to the realization that true nothingness may be impossible to conceive. Now science brings us to the edge of reality itself and quietly tells us the same thing. For centuries, scientists have reached into the dark, trying to see what lies beneath the visible world. Each generation has peeled back another layer, searching for the foundation beneath all foundations, the place where something gives way to nothing. But every time they look deeper, the silence reveals another hum, another motion, another structure. The closer they come to emptiness, the more they find that emptiness isn't empty at all. In the 17th century, the notion of a vacuum, a true space devoid of matter, was still controversial. Aristotle's ghost lingered in the minds of scholars, To many, the idea of a void was unthinkable. How could nature allow nothing to exist? But the age of experiment was beginning, and curiosity began to outweigh doctrine. Two men, Evangelista Torricelli in Italy and Blaise Pascal in France, performed a simple but profound experiment. They filled a glass tube with mercury, sealed it, and inverted it into a basin. A gap formed at the top of the tube, a clear, silent pocket where the mercury did not rise. That space, they realized, was a vacuum. Nature had allowed it. The ancient rule, nature abhors a vacuum, was broken by a column of mercury and human patience. This was the first glimpse of nothing as a measurable condition, a physical fact, rather than a metaphysical fear. For the first time, nothing could be made in a laboratory, not a cosmic mystery, but a small shining void under glass. But even this void made people uneasy. If light could travel through space, surely there must be something there for it to move through a medium invisible and all-pervading. Physicists called it the ether, a subtle fabric that filled the cosmos, carrying starlight from one world to another. It was thought to be the essence of stillness, the silent sea through which all vibrations passed. For nearly 2 centuries, the ether reigned as the quiet background of physics. Then came Einstein. In 1905, his theory of special relativity erased the need for such a medium. Light, he showed, needs no carrier. It moves through the geometry of space itself, not in something, but as something. Space is not a void to be filled, but a structure with its own integrity, its own laws. The ether dissolved. And for a moment, science seemed to have found true emptiness again. A universe of pure geometry, elegant, silent, bare. But the silence did not last. The 20th century opened like a curtain revealing another layer of reality. Quantum mechanics. Strange probabilistic shimmering entered the stage. And with it came a new definition of the void. In classical physics, a vacuum is simple. Remove all matter and nothing remains. In quantum physics, this is impossible. Even when every particle is gone, the fields remain. Invisible, omnipresent, they ripple through every corner of space. Each particle we know, electron, photon, quark, is simply an excitation, a vibration, a fleeting wave in one of these fields. And those fields cannot be switched off. At their lowest possible energy, they still fluctuate. Tiny pulses of energy called quantum fluctuations appear and vanish endlessly. Particles arise from the void, live for a breath of time, and fade again into the foam. The vacuum becomes a storm of potential not static, but alive with uncertainty. This is not poetic imagery, it is measurable. In 1948, 2 Dutch physicists, Hendrik Casimir and Dirk Polder, predicted something remarkable. If 2 uncharged metal plates were placed very close together in a vacuum just a few nanometers apart, they would attract each other ever so slightly, even though nothing lay between them. The cause was the vacuum itself. Between the plates, only certain wavelengths of quantum fluctuations can exist. Outside, all wavelengths are allowed. That imbalance in vacuum energy pushes the plates together. In 1997, scientists measured this force precisely. It was real. The emptiness of space exerts pressure. The nothing between the plates is full of restless energy. Even when stripped of all particles, the vacuum hums with existence. Imagine that for a moment, a universe where even silence has weight, where nothing presses gently against the edges of being. These vacuum fluctuations add up to what is called zero-point energy, the minimum energy any field can have even when seemingly at rest. It's not the absence of motion, but the smallest possible motion. Not the absence of light, but the faintest shimmer below detectability. According to quantum theory, every cubic centimeter of empty space contains an enormous amount of energy, far more than the total energy of all visible matter. We cannot easily extract it, but it shapes the universe nonetheless. It may even help drive the cosmic expansion we see today through what we call dark energy, the mysterious force causing galaxies to drift apart faster and faster. In this sense, nothing forms the stage not only for existence but for its acceleration. It is the quiet engine beneath all movement. So when we look at the vacuum, we no longer see a blank canvas. We see the ocean floor, dark, immense, restless. And from that ocean, the waves of being continually rise. Every particle in the universe corresponds to a field that fills all space. There is an electromagnetic field for photons, a quark field for matter, a gluon field for nuclear forces, a Higgs field for mass. Even if the universe were cooled to absolute zero and emptied of all visible matter, these fields would still stretch endlessly across it. They do not begin or end. They are space itself. In this view, empty space is just the lowest energy configuration of all these overlapping fields, a web of invisible presence. What we call something particles, forces, energy are simply regions where this web is vibrating in particular patterns. The Higgs field, discovered experimentally in 2012, is a perfect example. It never fades to zero. Even in a vacuum, it maintains a constant background value, a quiet ocean that gives mass to every particle that passes through it. Without this field, the universe would be a blur of light and motion, but no matter, no structure, no stars. In that sense, the Higgs field is the still water that allows the ripples of reality to take shape. So even nothing, when examined closely enough, becomes a kind of something too subtle to name, a fullness that masquerades as absence. Physicists now suspect that on the tiniest possible scales, around 10 to 35 meters, the so-called Planck length, even space and time lose their smoothness. They become turbulent, frothing, uncertain. This is sometimes called quantum foam, a ceaseless dance of microscopic fluctuations where space-time itself bends and twists like waves on a restless sea. In that foam, there is no fixed geometry, no clean separation between here and there. Space itself flickers in and out of definition. Tiny wormholes may open and close in less than an instant. The very fabric of existence becomes a blur of probability. And yet this chaotic foundation might be the seedbed of the cosmos, a place where the laws of physics are not broken but not yet born, a prelude to the stage on which time and space will later perform. What we call nothing could be that foam, the smallest vibrations of an unformed reality still half asleep. In 1973, physicists Edward Tryon and others suggested something audacious. Perhaps the entire universe began as a quantum fluctuation in this vacuum energy. After all, in quantum physics, energy can briefly appear from nowhere as long as it vanishes again quickly enough. But what if one of those fluctuations was vast, large enough to inflate into a universe? If the total energy of that universe were zero, with positive matter balanced by negative gravitational potential, than the laws of physics might permit it. A cosmos born spontaneously from the vacuum's own restless potential. In this picture, nothing is not a void, but a fertile womb, a field of possibility that sometimes rarely blossoms into a universe. And if quantum laws apply everywhere, then such creation might not be unique. Many universes could emerge and fade continuously, like bubbles on an eternal ocean of potential. This idea leads naturally into the concept of the multiverse, but we'll drift there later. For now, the key insight is this: even the deepest scientific nothing contains the potential for everything. If you could travel far into intergalactic space, past every star, past every cluster, beyond the faint glow of the cosmic background, you might think you've reached pure emptiness, a region utterly devoid of matter. But if you could measure it finely enough, you'd find radiation flickering everywhere. Microwave photons left from the Big Bang still cross the dark, like embers that refuse to cool. And even where those photons fade, the vacuum remains restless. Invisible particles appear and disappear faster than thought. Virtual pairs of electrons and positrons borrow energy from the void, repay it, and vanish again, leaving no trace except the fields they briefly disturbed. If you could listen to the silence of that emptiness, you might hear a low hum, a vibration older than stars, a kind of background breath that never ends. This is not metaphor, but measurement. We can detect the effects of these fluctuations on the behavior of atoms, on the shifting of light near magnetic fields, even on the structure of galaxies. Nothing has fingerprints. In the classical sense, nothing meant the total absence of being. In the scientific sense, it has become the deepest expression of being possible. A quiet fullness, a ground state from which form emerges again and again. There is a kind of poetry in that reversal. Science, often seen as the language of precision, ends up circling the same mystery that poetry and philosophy once held dear: the unity of emptiness and existence. When we speak of vacuum energy, we are really describing potential itself. And potential is the quiet twin of being. It is what waits before it becomes. Imagine a field stretching infinitely in every direction, invisible yet everywhere. Now imagine a single fluctuation, a spark, a crest in the field spreading outward. That crest becomes matter energy, galaxies' consciousness. The field remains humming softly underneath. The cosmos expands, but the foundation is unchanged. From this view, creation is not a single event, but an ongoing process, a continuous conversation between energy and stillness, between presence and absence. The Big Bang may have been only one syllable in that endless exchange. When we return to philosophy after this long, quiet journey through physics, the circle closes neatly. Leibniz asked, "Why is there something rather than nothing?" Quantum physics answers softly, because nothing is unstable, because nothing cannot sit still. The vacuum trembles, and in trembling creates. Its restlessness is the origin of motion. Its fluctuations are the seeds of stars. In that sense, something and nothing are not opposites, but phases of the same deeper reality, the same ocean alternating between wave and calm. And perhaps this is the ultimate reconciliation between science and spirit. Both tell us that the void is not void. Both whisper that even in the dark there is movement, there is potential, there is quiet life. So when you look into the night sky, when you see that infinite black between the stars, you are not seeing absence. You are seeing the quantum sea itself, ancient and fertile, shimmering beneath perception. You are seeing the place from which everything rises again and again endlessly. The philosophers dreamed it. The scientists measured it. Both in their own way found the same truth, that the silence before creation is not truly silent. It hums with the music of possibility. The deeper we look into the fabric of nothing, the more alive it becomes. Quantum fields tremble, invisible particles flicker, and energy folds itself into existence again and again. It feels less like absence and more like a kind of breathing, slow, eternal, effortless. And yet even with this quiet fullness, a question remains. If the vacuum hums with potential, what was the moment when that potential became the universe? When did the hum turn into the first note? The story we call the Big Bang tries to answer that. But even that name is misleading. It wasn't a bang in any ordinary sense. There was no explosion in space, no detonation into emptiness. Instead, space itself expanded from something infinitesimal, dense and hot into something vast and cooling. The Big Bang was not a blast within the universe. It was the universe itself beginning to breathe. Still, one question continues to haunt every cosmologist, every philosopher, every quiet midnight thought. What happened before that breath began? Was there truly a before? Or is that very idea a misunderstanding, a shadow of human logic cast on something far beyond it? Let's drift closer to that edge, the edge where time itself may lose its meaning. According to general relativity, if we trace the expansion of the universe backward, we reach a moment when the density of energy becomes infinite and the curvature of space-time itself collapses. This point is called a singularity, a place where the equations that describe the cosmos break down completely. In that singular state, the universe has no size, no structure, no time. All distances shrink to nothing. All matter condenses into a single mathematical point where known physics cannot survive. But the singularity is not a thing. It's a signal that our models have reached their limit. It's where the map ends, where the road of classical reasoning simply dissolves into fog. And beyond that fog lies the question of before. In the language of relativity, time itself begins at the Big Bang. There was no earlier because time is not something that flows independently. It is part of the universe's fabric. If that fabric had not yet formed, then before has no meaning, no framework, no duration, no existence. To ask what came before time is like asking what lies north of the North Pole. The question itself unfolds into silence. And yet, our minds continue to reach for it. We want to imagine that even before the first moment, there was something, a cause, a condition, a spark. It's in our nature to look for origins. Even the thought of nothing calls for a beginning. Some cosmologists believe the universe has no beginning at all, that it expands and contracts endlessly like the tide of a cosmic sea. This is known as the cyclic model or the oscillating universe. In this vision, the Big Bang is not a unique event, but part of an eternal rhythm, a breath that never truly stops. Expansion gives way to contraction. Contraction collapses into compression. And from that density, another universe is born. Each cycle could erase the memory of the one before it. Yet, the energy persists, reshaping itself into new configurations, new laws, new possibilities. It is a universe that neither begins nor ends. It simply pulses. Modern versions of this idea draw upon Einstein's equations and the properties of dark energy. If the energy density of the cosmos changes over time, it could reverse the expansion, bringing all galaxies back together. Then, when everything converges, the pressure and heat could ignite another expansion, another Big Bang. Even though evidence suggests our universe's expansion is accelerating, making collapse unlikely, the cyclic idea continues to inspire. It paints a picture of reality not as a one-way story, but as a heartbeat. Creation and dissolution endlessly recurring. In such a cosmos, before is replaced with again. Nothingness becomes a pause between worlds, a quiet exhale before the next inhale of creation. One of the most compelling modern theories comes from the 1980s, the concept of cosmic inflation. It proposes that in the earliest fraction of a second, the universe expanded exponentially faster than light, faster than imagination. This expansion may have begun not from a singularity, but from a quantum fluctuation in a so-called false vacuum, a state of unstable energy within the quantum fields of space itself. Imagine the universe as a field caught in a state of tension, like a ball balanced at the top of a hill. Eventually, it rolls down, releasing energy as it moves. That release becomes expansion, the birth of space and time, the dawn of matter and light. In this view, the Big Bang was not the creation of space from nothing, but the transformation of one quantum state into another. Before our universe, there may have existed a field poised in stillness, an ocean of potential energy waiting to cascade into being. When that energy decayed, it didn't happen in one place, but everywhere at once, an eruption of expansion that filled the void with space-time itself. This process, though brief, shaped everything that followed. The universe smoothed out, flattened and cooled, giving rise to galaxies, stars, and the cosmic background radiation we still observe today. The false vacuum was not nothing. It was everything condensed quiet and ready to unfold. If inflation can happen once, it can happen again. And again. Quantum physics allows fluctuations everywhere at every scale. This leads to the concept of eternal inflation, an unending process where countless universes emerge like bubbles in an infinite sea. Each bubble forms when inflation slows and stops in a particular region, creating a universe with its own physical laws and constants. But the larger multiverse continues inflating endlessly, generating new bubbles, new universes, each isolated from the others by expanding space. In some of these bubbles, stars may never form. In others, physics may differ so much that atoms cannot exist. And in at least one ours, the balance is just right for galaxies, chemistry, and consciousness. In this picture, nothing before the Big Bang is replaced by something deeper, a metavacuum, a higher dimensional energy field from which universes continually arise. Each one begins with its own Big Bang, its own unfolding of time. The multiverse model does not so much answer the question, what came before, as dissolve it. If universes are always forming, there is no single beginning, only perpetual creation. Eternity replaces origin. The void becomes a living ocean of beginnings. Other theories go even further, questioning whether the singularity ever existed at all. Among these, loop quantum gravity offers a vision where space itself is quantized, woven from tiny loops of finite structure. According to this framework, the universe cannot collapse to an infinite point because space has a smallest possible size. Instead, when density reaches that limit, gravity becomes repulsive rather than attractive, causing a quantum bounce. In this scenario, our Big Bang was the rebound of a previous universe that had contracted to a minimal volume and then expanded again. Time did not begin. It reversed. Before our expansion, there was contraction, a universe falling inward before rising once more. It's a graceful solution. No singularity, no absolute beginning, just a continuous cycle of collapse and renewal. The nothing before our universe was not void, but a mirror image cosmos, dense and luminous, folding into itself before unfolding anew. And in that reflection, we glimpse something profound, that maybe creation is never an act of birth, but of transformation. Energy changing state. Silence becoming sound again and again. Beyond even quantum gravity lies another possibility, one woven from the mathematics of string theory and M theory. In these models, the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings existing in up to 11 dimensions. Our universe then may be a three-dimensional brain, a membrane floating within a larger multidimensional space. According to one idea called the ekpyrotic or brain collision model, the Big Bang occurred when two such brains collided. Their impact released vast energy, igniting our universe in light and motion. Afterward, the brains separated again, drifting apart through higher dimensional space. If that's true, the universe's origin wasn't an explosion from nothing but the result of interaction between higher dimensional realities, a cosmic meeting that continues beyond our view. And just as waves ripple across a pond, those collisions might happen again, birthing new universes across the vast extra dimensions of existence. Even in this model, nothing becomes relative. What looks like emptiness from within our three-dimensional world may be alive with unseen geometry, higher spaces brushing past one another, exchanging energy through invisible membranes. Creation, then, is not spontaneous, but relational. The universe arises not from absence, but from contact. And yet, there remains one bold idea, one that loops back toward our original question. Could the universe truly have come from nothing? Physicists such as Alexander Vilenkin have proposed that the entire universe might have emerged spontaneously from a state of zero total energy, a quantum event requiring no external cause. In this framework, the laws of quantum mechanics allow for spontaneous creation. Energy fluctuations can momentarily appear from nothing as long as the total energy, including the negative energy of gravity, sums to zero. Our universe, vast and glowing, might therefore balance perfectly the positive energy of matter and light countered by the negative curvature of space. In that balance, the whole could arise from nothing, a self-contained system needing no outside source. To our intuition, this feels impossible. But mathematically, it may be entirely consistent. In quantum mechanics, even nothing has rules, and those rules paradoxically allow for creation. The universe, then, could be its own cause, a closed loop of being arising from the potential written within the fabric of emptiness itself. Each of these theories, cyclic, inflationary, quantum, multidimensional, carries its own poetry. Each offers a different answer to the same question, or perhaps a different way of asking it. Some suggest that before the Big Bang was another universe, some that before has no meaning at all, some that before was an ocean of potential waiting to stir. But all of them share a quiet truth. There is no such thing as absolute nothingness. Even in our boldest theories, the void has structure. It hums with possibility. It bends under the weight of laws. It breathes like something alive. So when cosmologists describe the beginning, they are not imagining creation, ex nihilo, but transformation, one state becoming another. The Big Bang was not a start, but a change. A phase transition in the cosmic field, a turning of the great wheel. The more we learn, the more the beginning looks less like a single spark, and more like an eternal unfolding, one layer after another, each giving rise to the next. And perhaps this is the quiet revelation hidden in modern cosmology, that the universe was never truly born. It has always been becoming. It has always been breathing, expanding, pausing, collapsing, rising again. When we ask what existed before the Big Bang, we are really asking what it means to exist. We're asking how time can begin, how laws can arise, how being can emerge from potential. We're asking in softer words the same question Leibniz asked. Why is there something rather than nothing? The scientist measures. The philosopher reflects. But both stand at the same horizon, looking into the same silence. At that edge, the difference between something and nothing begins to blur. Perhaps they are not separate at all, but two faces of one deeper truth. Like day and night, they define each other. Like sound and silence, they complete each other. Creation and void, partners in a rhythm as old as time itself. The Big Bang, then, was not a beginning out of nothing, but a movement within everything, a gentle unfolding of the cosmic potential that had always been waiting to breathe. So when we gaze into the dark sky and imagine the start of it all, perhaps we are really seeing the continuation of something timeless, a pulse that never began and will never end. A motion within stillness, a universe that dreams itself into being again and again, quietly, endlessly. In the silence that follows the question of beginnings, we arrive at the story. Science tells most clearly the story not of what came before, but of what followed. The Big Bang, once only a hypothesis, has become the quiet cornerstone of modern cosmology. It does not claim to describe the first instant itself, only the unfolding that came after when the young universe took its first luminous breath. From that moment onward, the cosmos began to reveal itself. Light stretched, matter cooled, and structure began to form. Through this unfolding, through the long patience of time, we can trace our own origins, not as an act of creation in an instant, but as a slow flowering that continues still. To understand this story is to look back through billions of years, like following the fading ripples of a wave that began in unimaginable heat. Each layer of evidence is another whisper of the universe remembering itself. Each discovery brings us closer to that luminous dawn. In the early 20th century, astronomers believed the Milky Way was the entire universe. The sky to them was a closed garden of stars. But as telescopes improved faint spirals of light, appeared galaxies far beyond our own. In 1929, Edwin Hubble made a discovery that changed everything. By measuring the light from these distant galaxies, he found that their spectral lines were shifted toward the red, a sign that they were moving away from us. And, not randomly but in proportion to their distance. The farther away a galaxy was, the faster it receded. This was not motion through space, but the expansion of space itself. The universe was stretching gently continuously like the surface of a rising tide. And if it was expanding now, it must once have been smaller, denser, hotter, closer. From this insight, the idea of the Big Bang emerged not as an explosion, but as the natural consequence of cosmic motion. Every point in the universe receding from every other, not because of a central blast, but because space itself is unfolding. Even now, as you breathe, distant galaxies drift farther apart, their light reddening as it travels through the expanding fabric of space-time. The night sky you see is not static. It is an ongoing motion, a quiet exhalation, billions of years in length. Hubble's law became the first great pillar of the Big Bang. The discovery that the universe is not fixed but alive in expansion. The second pillar came from sound, or rather from the faint echo of ancient light. In the 1940s, physicists George Gamow, Ralph Alpher, and Robert Herman predicted that if the universe once existed in a hot, dense state, it should have left behind a residue of radiation cooled and stretched by expansion, but still filling all of space. They called it the cosmic microwave background, or CMB, of fossil light from when the universe was young. For decades, it remained a theoretical whisper. Then, in 1965, two radio engineers, Arno Penzias and Robert Wilson, were testing an antenna in New Jersey when they detected a persistent hiss, a signal that came from every direction, constant and unrelenting. It was the echo of the early universe itself. That faint radiation had been traveling for nearly 14 billion years, cooled to just 2.7 degrees above absolute zero, bathing the cosmos in a uniform glow. It confirmed what the Big Bang predicted, that the universe was once a fireball of radiant energy, now stretched into a gentle background hum. When scientists mapped the CMB in detail, first with COBE in the 1990s, then WMAP, and later Planck, they found subtle ripples, temperature fluctuations of 1 part in 100,000. Those ripples were the seeds of galaxies. The first small imbalances in density that gravity would later shape into stars, clusters, and cosmic filaments. The CMB is not just a remnant. It is the oldest light we can ever see, a boundary beyond which the universe is opaque. To look into it is to look into a kind of cosmic childhood when everything glowed with a soft, uniform fire. Even now, that ancient radiation passes through you as you read this photons born before the first stars, moving silently through your body, whispering the temperature of eternity. The third great pillar of the Big Bang lies in chemistry, the distribution of the lightest elements. If the universe began as a hot plasma, it must have cooled enough for protons and neutrons to fuse, forming the simplest atomic nuclei. This process, known as Big Bang nucleosynthesis, took place within the first few minutes of cosmic time when temperatures dropped below 1 billion degrees. In that brief window, hydrogen fused into helium with trace amounts of lithium and beryllium. Then, as the universe expanded further, the temperature fell too low for fusion to continue. Billions of years later, when astronomers measured the composition of the oldest stars, They found exactly those predicted ratios, roughly 75% hydrogen, 25% helium, and minute traces of lithium, precisely what the Big Bang model anticipated. The heavier elements, carbon, oxygen, iron, would come much later, forged in the hearts of stars and scattered by supernovae. But the light elements are fossils of the first few minutes, silent witnesses to the universe's earliest chemistry. So we see that the universe carries its history not only in light, but in matter itself, in the proportion of atoms that fill its breath. The Big Bang is not one event, but a sequence, a symphony of transformations stretching across unimaginable spans. Each stage follows naturally from the one before, each setting the conditions for the next. Let us move through those stages quietly, step by step, from the first instant to the dawn of structure. Here, physics dissolves. The universe is smaller than an atom, denser than any star, hotter than any conceivable fire. Gravity and quantum mechanics merge into a single unknown force. Space and time flicker like foam, indistinct and restless. We do not yet know the laws that govern this domain. They remain hidden beyond the veil of our theories. But within that frothing quantum sea, the seeds of everything begin to stir. Suddenly, the universe expands exponentially, not outward into space, but by creating space itself. Every point separates from every other faster than the speed of light, smoothing and flattening the cosmos. Quantum fluctuations stretch to cosmic scales, becoming the imprints that will one day form galaxies. In less than a heartbeat, the universe grows from subatomic to macroscopic, a transformation of scale so immense that human imagination falters before it. Then, inflation ends. The field driving it decays, releasing a flood of energy and matter, the true beginning of what we call the hot Big Bang. The universe now fills with a dense plasma of quarks, gluons, and leptons. Temperature 10 trillion degrees. Matter and antimatter are produced in nearly equal amounts, annihilating in flashes of light, a slight asymmetry. One extra particle of matter for every billion of antimatter ensures that something remains. That slight imbalance is why there is anything at all. The quarks begin to cool and bind, forming protons and neutrons, the building blocks of atomic nuclei. The young cosmos continues to expand and cool. Particles slow their furious motion. Neutrinos decouple, streaming freely into space. A ghostly background still passing through us today. Protons and neutrons begin to form stable combinations, though most remain separate until the great fusion to come. Time begins to stretch into recognizable flow, not timeless quantum chaos, but measurable sequence. The first second has passed. Electrons, positrons, and neutrinos dominate the cosmic soup. Matter and radiation interact constantly, an ocean of collisions. Gradually, as temperatures fall below 1 billion degrees, electrons and positrons annihilate. Only a small fraction of electrons remain balanced against protons to form the first hydrogen atoms, though not yet bound. The energy density shifts from radiation to matter. The universe begins to cool into clarity. Protons and neutrons fuse. Hydrogen becomes helium in ratios that match the cosmic recipe we now observe. Light fills the universe, a radiance that will continue to expand and thin, slowly becoming the cosmic background radiation. By the end of this brief period, the elemental pattern of the universe is set. The fire fades into transparency. Atoms finally form. Electrons bond with nuclei, allowing photons to travel freely for the first time. The fog of plasma clears, and the universe becomes transparent. This moment is what we now observe as the cosmic microwave background, the release of light that still glows, still drifts through every corner of space. The universe for the first time can be seen. After recombination, the cosmos enters a long silence. No stars yet burn, no galaxies yet gleam. Only clouds of hydrogen and helium drift slowly, pulled together by gravity. Tiny fluctuations in density born from quantum ripples stretched by inflation begin to amplify. The first structures take shape in the dark. Space is vast, quiet waiting. It is the stillness before the first sunrise. Then the first stars ignite massive, brilliant, short-lived. Their light rayonizes the surrounding hydrogen, transforming the darkness into transparency once again. Galaxies coalesce their shapes, sculpted by gravity's patient pull. Clusters form filaments, weave, and the large-scale structure of the universe begins to take form. The cosmos transitions from chaos to pattern, from uniform glow to the intricate web we now observe. Now the universe is vast and still expanding. Galaxies drift farther apart. New stars are born, even as old ones die. Dark matter shapes the invisible scaffolding of structure, while dark energy drives the accelerating expansion. Even here, in the quiet of now, the story continues. Yet even with this elegant timeline, mysteries remain. When astronomers measure the universe's expansion rate using nearby galaxies, they get one value. When they infer it from the early universe, they get another. This discrepancy, known as the Hubble tension, hints that something in our understanding is incomplete. Perhaps new physics lies hidden in the gap, a change in dark energy, an unrecognized particle, a subtle curvature in space-time. Or perhaps the universe is reminding us that our equations, like our senses, are only partial truths. Each refinement brings us closer, but never to finality. The cosmos always leaves a margin of wonder. When we stand beneath the stars, we stand within this evidence. Every photon that reaches your eye began a journey billions of years ago through expanding space. Its wavelength stretched its energy, softened its message, preserved. In that faint light is written the entire history of time. Galaxies drifting apart, atoms forming from plasma, matter condensing into suns that will one day die and scatter themselves into life. The Big Bang is not distant. It is within everything, still unfolding through every breath and heartbeat. We are its continuation, its quiet extension into awareness. Science, in its precision, describes the measurable, but behind its numbers lies a rhythm that feels almost meditative. The expansion of the universe mirrors the expansion of thought, both stretching toward what lies beyond their reach. The cooling of matter mirrors the settling of the mind. The cosmic background hum echoes the silence within which ideas rise and fall. We can look at the universe as a mechanism or as a melody. Either way, it plays in time, and we are part of its sound. The Big Bang was not the universe's birth. It was its first motion. What followed was not chaos, but slow self-organization. Gravity, light, and time cooperating to create complexity. And though we now see galaxies receding, stars dying, and expansion accelerating, this too is creation. A quieter, colder, subtler form of becoming. The universe is not winding down. It is changing tempo. Even as it grows thinner and darker, new stars still flicker into being. Even as galaxies drift apart, the quantum fields beneath them remain alive, vibrating softly, whispering the same energy that once ignited the first light. The Big Bang is not behind us. It is within us, around us, continuing a wave still moving outward through time. When you close your eyes, imagine the night sky as it truly is, not an expanse of static stars, but a living history of light still in motion. The cosmic expansion continues silent yet unstoppable, and even now new beginnings shimmer at the edge of what we can see. The first fire still burns, not in explosions, but in understanding in the mind that looks up and wonders. That curiosity is the same force that once turned energy into matter and silence into song. The Big Bang gave us a story of becoming a tale woven from evidence and light, yet even within its quiet precision, shadows remain. For every answer that has brought the cosmos into focus, another question has unfurled at the edge of knowing. Like stars hidden by brighter ones, the mysteries lie behind the clarity unseen but deeply present. We know how the universe expands. We can trace its first seconds, measure its glow, and predict its distant fate. But what breathes beneath those equations? What whispers at the boundaries of knowledge in the silence before and the silence beyond? Science, like the cosmos, continues to expand. Each discovery, no matter how complete it seems, leads inevitably to the next horizon, the next not knowing. These mysteries are not flaws. They are the pulse of curiosity itself. They are the spaces between stars allowing the light to shine. Let us drift through those spaces now, the unanswered questions that shimmer like constellations of wonder. Even now, this remains the most elusive question. Relativity tells us that time began with the Big Bang, that before has no meaning, because time itself is part of the unfolding fabric that began then. Yet the human mind cannot rest within such stillness. We yearn to imagine what lay beyond the first light, what dream preceded awakening. Was there a universe before ours, collapsing inward until it rebounded into new expansion? Was there a timeless quantum state vibrating silently until it gave birth to geometry and motion? Or does the question dissolve entirely, like trying to imagine the color of silence? Some cosmologists imagine that the universe could be one bubble among countless others, each arising from the same underlying vacuum energy. In that eternal sea, our Big Bang was not the first, nor will it be the last. Creation becomes not an event, but a continuous process. Others imagine a bounce-a-heartbeat of existence contracting and expanding without beginning or end. In those models before the Big Bang was not nothing but another phase, a previous universe folding into itself to become the seed of ours. And still, some suggest that time itself is an illusion born from entropy, that before and after exist only as directions within a greater timeless whole. In that stillness, there is neither origin nor end, only being forever shifting shape. Whatever the answer, it remains hidden behind a veil the universe does not yet allow us to lift. But perhaps the value lies not in knowing, but in continuing to wonder. In that wonder, we stay connected to the mystery that began all things. Every particle of matter has a mirror opposite an antimatter twin identical in mass but opposite in charge. When the two meet, they annihilate in pure energy. In the first microseconds after the Big Bang, matter and antimatter should have existed in equal amounts. If the universe were perfectly balanced, they would have destroyed each other completely, leaving behind only light. No galaxies, no stars, no us. And yet, somehow, a tiny imbalance, perhaps one extra particle of matter for every billion of antimatter, allowed everything we see to remain. This subtle asymmetry, called baryogenesis, is one of the great unsolved mysteries. Why did matter win by so slight a margin? What small imperfection in the symmetry of creation made the universe lean toward existence instead of erasure? Physicists have found hints in the weak nuclear force processes that slightly favor matter over antimatter. But these effects are too faint to explain the enormity of the outcome. There must be something more, something we have not yet seen. Perhaps hidden particles or forgotten interactions in the earliest plasma. Perhaps laws beyond our current understanding written into the structure of the quantum fields themselves. That imbalance, that 1 in a billion imperfection, became the foundation of everything solid, luminous, and alive. It is a reminder that creation often arises not from perfection, but from the smallest asymmetry. A whisper of difference that tips the balance toward being. Look into the night sky, and what you see is only a fraction of what exists. The stars, the galaxies, the glowing clouds of gas, all the visible matter together, accounts for less than 5% of the universe. The rest is unseen. It does not shine, does not absorb, does not emit light. And yet its gravity shapes everything. This invisible mass is called dark matter, and it outweighs all the luminous material we know by nearly 5 to 1. We do not yet know what it is made of. It might be composed of exotic particles, WIMPs, axions, or sterile neutrinos that rarely interact with ordinary matter. It might be the shadow of another field hidden from direct detection. Or perhaps our understanding of gravity itself needs revision. But the evidence of its presence is overwhelming. We see its pull in the rotation of galaxies where stars move faster than visible matter allows. We see it in gravitational lensing, where light bends around invisible mass. We see it in the cosmic web, where it forms the unseen scaffolding upon which galaxies assemble. Without dark matter, the universe could not have formed the structures we observe. It is the silent architecture of the cosmos, the dark backbone of creation, and yet it remains entirely invisible. We live within its field, surrounded by its weightless presence, unaware. It is the darkness that makes the stars possible. If dark matter binds the universe together, dark energy drives it apart. This mysterious force, discovered in the late 1990s, is the cause of the universe's accelerated expansion. Before then, scientists believed gravity would gradually slow the cosmic expansion. But distant supernovae revealed something unexpected. Galaxies are receding faster than before. The universe is not coasting, it is speeding up. To explain this, cosmologists invoked dark energy, an unseen pressure that acts opposite to gravity, pushing space-time outward. It may be the energy of the vacuum itself, the residual hum of quantum fields, or it may be something even deeper, a property of space-time we cannot yet define. We measure its strength, but not its essence. It accounts for nearly 70% of all cosmic energy, yet we know almost nothing about it. Some models suggest it is constant, the same everywhere always. Others imagine it changes slowly, evolving as the universe expands, hinting that our cosmic acceleration may one day cease or reverse. Whatever it is, dark energy determines the ultimate fate of the cosmos. If it remains constant, the expansion will continue, endlessly scattering galaxies until even light cannot bridge the growing voids. If it grows stronger, it could tear even atoms apart, a quiet disassembly of everything. If it weakens, gravity could reclaim the cosmos, drawing it back into a final collapse. For now, it remains the softest of mysteries, invisible, untouchable, but written across the sky itself. The universe breathes through it, and we are carried along. At the smallest scales and the greatest densities, two great frameworks meet and fail to align. Quantum mechanics describes the realm of the very small particles' fields, probabilities. General relativity describes the realm of the very large stars' galaxies, the curvature of space-time. Each theory works perfectly in its own domain, yet together they resist unification. The singularity at the beginning of the Big Bang, or at the center of a black hole, demands both a theory of quantum gravity that does not yet exist. Many have tried to build it. String theory weaving particles from vibrating loops of energy in higher dimensions. Loop quantum gravity building space-time from finite loops of geometry. Each offers glimpses of coherence, but the full picture remains elusive. Until such a theory emerges, our understanding of the universe's first instant and its deepest structure remains incomplete. We stand between two languages that describe the same song, differently listening for the harmony that unites them. Perhaps that harmony lies not in equations, but in a new conception of what space and time truly are, not fixed backdrops, but emergent patterns, like ripples on an ocean of deeper stillness. In recent years, astronomers have faced a new riddle. The Hubble constant, which measures the rate of the universe's expansion, gives conflicting results depending on how it is measured. When we observe the nearby universe, galaxies, and supernovae, the expansion seems faster. When we infer it from the early universe through the cosmic microwave background, it appears slower. The difference is small, but persistent beyond the margin of error. This tension could signal unknown physics between the early and modern cosmos, perhaps new particles or variations in dark energy or subtle curvature beyond current models. Or it could be the echo of systematic effects we do not yet understand. Whatever the cause, it reminds us that the universe still holds surprises. Even in the precision of our instruments, the cosmos maintains its mystery, a soft resistance to complete comprehension. Time flows, or so it seems. From past to future, from order to disorder, from birth to decay. But the laws of physics are largely indifferent to direction. They work the same forward or backward. The arrow of time arises not from those laws, but from the gradual increase of entropy, the spreading of energy, the smoothing of differences. Still, why did the universe begin in such a low entropy state? Why so ordered, so improbably precise? Some theorists suggest that time's flow is a property of our perception, not of the cosmos itself, that past and future coexist as a whole, like the pages of a book already written. Others imagine that new time is constantly being created as the universe expands, that the arrow of time points outward with the growth of space. Time, like space, may not be fundamental at all. It may emerge from correlations within deeper quantum states, an illusion woven by change itself. And if time is emergent, then the question before the Big Bang dissolves into meaninglessness. There was no before, because there was not yet was. Among all mysteries, one stands apart: the fact that the universe became aware of itself. That out of fields and particles, stars and chemistry, something arose that could ask questions, remember, and dream. Science does not yet understand how consciousness emerges. We can describe the activity of the brain, but not the inner light of awareness itself, the quiet sense of being that observes all else. Some philosophers and physicists have begun to wonder whether consciousness is not produced by matter, but fundamental to reality, perhaps as intrinsic as space and time. If so, the universe may not merely contain awareness, but express it. Each mind, then, would be a small window through which the cosmos perceives itself. This is not a scientific claim, but a reflection, a thought that brings the story of nothing full circle. If awareness can arise from matter, and matter from fields, and fields from quantum potential, then perhaps nothing was never truly nothing. Perhaps the capacity to know was always latent in the structure of existence, the quiet potential for wonder. When science reaches its limits, silence becomes its most honest expression. We can describe, measure, and model, but beyond the equations lies a horizon that cannot yet be crossed. That horizon is not failure. It is the natural boundary between knowledge and mystery, a boundary that moves outward each time we step forward. Every unanswered question is an invitation, every uncertainty a space for discovery. In the dark between the galaxies, in the quiet between thoughts, in the spaces between known and unknown, there too lies the essence of creation. The universe keeps some secrets, not to withhold them, but to give meaning to the act of seeking. Without mystery, there would be no science, no curiosity, no consciousness at all. The unknown is the breath that keeps knowledge alive. When we look back across the arc of cosmic history, from the first light to our present moment, we see both immense progress and endless distance. We have measured the universe to astonishing precision, yet the most profound truths remain veiled. And there is beauty in that incompleteness. For what is mystery if not the universe's way of remaining infinite? What is uncertainty if not a promise that there is always more to learn, more to feel, more to become? The unknown does not diminish the cosmos. It enriches it. It gives us room to wonder, and in that wonder, to grow. Even the mysteries themselves are part of the unfolding. They are the spaces where new light will one day shine. So let us not seek to close the circle, but to move gently along its edge, to stand in awe of what is revealed and in reverence for what remains concealed. For the greatest truth may be this, that the universe, vast and ancient, is not a puzzle to be solved, but a living presence to be witnessed moment by moment, breath by breath, as it continues to expand within and beyond us. The mysteries of the cosmos do not close the book of knowledge. They open it wider. Each unknown, each unanswered question reveals not emptiness, but invitation. The universe withholds just enough to keep us searching, and in that search, consciousness unfolds. In the previous part, we wandered through the unlit corridors of modern cosmology, dark matter, dark energy, the birth of time, the silence before creation. Now we pause to reflect, not to solve, but to listen, to ask not what the universe is, but what it means to know it at all. Science gives us structure. Philosophy gives us depth. Together, they form a language of wonder, one that moves beyond numbers into the realm of awe. This part is that quiet middle ground where observation meets contemplation and the mind meets the cosmos. Here, nothing and something lose their boundaries, merging into a deeper rhythm, a unity that pulses through matter, energy, thought, and silence alike. The universe is not a thing but a process, a becoming continuous and unhurried. It does not exist in the way an object exists. It flows in the way music does, arising, evolving, fading, and beginning again. To observe it is to enter its movement. When a physicist traces the expansion of galaxies, when a philosopher wonders about being, they are part of that same motion, the universe reflecting upon itself. Every act of knowing is a continuation of creation. Each insight is another ripple through space-time, another pattern added to the infinite fabric of awareness. Even doubt, even mystery, is a form of participation, the cosmos thinking through us, trying to understand its own silence. Perhaps understanding is not about resolution, but resonance. When thought aligns with the rhythm of reality, even for a moment, there is harmony. And in that harmony, we glimpse something vast, that knowledge is not outside the universe, but one of its quietest expressions. Centuries ago, Leibniz asked, "Why is there something rather than nothing?" That question still hums beneath every equation, every telescope, every dream of science. Physics may explain how the universe evolves through symmetry, breaking inflation, quantum fluctuations, but it cannot easily answer why the laws themselves exist, why the fields are as they are, why there is law rather than lawlessness. And so philosophy steps in, not as competition, but as continuation. It dares to look into that silence and call it meaningful. Some thinkers suggest that existence is necessary, that nothing is unstable, that to be is the most natural state of all. Others argue that the laws of physics are mathematical inevitabilities, patterns that must exist in some form somewhere. Yet perhaps the truest answer lies in the question itself. Why is there something rather than nothing? Because to ask is already to affirm being. To wonder is to participate in the very existence we question. In that sense, the question answers itself. Awareness cannot inquire into non-being without proving being's reality. So the mystery turns inward, not, "Why is there something?" but "Why do I, this consciousness, arise to ask it?" The fact that we can ponder the origin of everything is itself a cosmic miracle. Atoms forged in ancient stars now compose the neural networks that think about those stars. The universe through us has developed the ability to reflect upon its own existence. This is not metaphor. Every cell in your body is a condensation of cosmic history. The calcium in your bones was born in long-dead suns. The oxygen you breathe was formed by the fusion of earlier stars. The iron in your blood was released by supernovae. You are literally the universe remembering itself. When you look up at the night sky, the separation between observer and observed begins to dissolve. The gaze that studies the stars is made of the same particles that drift among them. It is all one system, one continuous unfolding of energy aware of its own motion. From this perspective, consciousness is not an accident of biology, but a property of complexity, a way for matter to experience its own existence. As the cosmos organizes itself into structure, structure eventually becomes awareness, and awareness becomes wonder. Perhaps consciousness was not added to the universe. Perhaps it was always implicit, waiting for the right conditions to awaken. In earlier parts, we traced the transformation of nothing from Aristotle's denied void to the quantum vacuum seething with energy. Now we can see that nothing and something are not opposites but partners. The vacuum is not absence, but foundation. The silence is not the end of sound, but the condition that allows music to exist. Without the stillness between waves, there would be no rhythm. Without the darkness between stars, light would lose its meaning. Every existence leans against non-existence. Every being defines itself through contrast. So perhaps nothing is simply the other side of being the unmanifest aspect of existence, always present, always waiting to give birth to form. It is the unseen rhythm that lets everything dance. When science describes quantum fields, it describes this same rhythm in mathematical terms. When philosophy speaks of potentiality or void, it speaks of it in symbols. Both point to the same truth, that the universe is not made of things, but of relationships between presence and absence, between becoming and resting. The ultimate reality then may not be something or nothing, but the dance between them, eternal, balanced, serene. The physical laws of our universe appear astonishingly precise. Gravity follows elegant curves. Light obeys exact symmetries. The constants of nature, the speed of light, the strength of forces, the masses of particles, are balanced so delicately that even a small change would erase the possibility of life. Why should the universe be so finely tuned? Why should mathematics, a creation of the human mind, fit the cosmos so perfectly? Some call it coincidence, a statistical inevitability in a vast multiverse of possibilities. Others see it as evidence of underlying necessity, that the laws must be this way or they could not exist at all. And a few whisper that maybe the universe is not a random structure, but an expression of order so deep that even randomness has its place within it. Whatever the explanation, one truth stands clear. The laws of nature are not separate from nature. They are the patterns of its being, the rhythm of its unfolding. They are the poetry of existence written in the language of numbers. And when we discover them, when a physicist writes an equation that captures the motion of galaxies, it is not invention, but recognition. We are not creating the laws. We are remembering them. We are remembering the way the cosmos breathes. In quantum mechanics, certainty dissolves. Position momentum energy, none can be fully known at once. The universe is built upon uncertainty, and yet that uncertainty gives rise to stability. This paradox is not merely technical, it is existential. Reality itself seems to prefer possibility to rigidity, flexibility to fixity. Perhaps uncertainty is the breath of the universe, the space that allows freedom, the gap that lets creativity enter. If everything were predetermined, the cosmos would be static, lifeless, mechanical. But in the gentle tremble of the quantum world, there is choice, variation, and beauty. It means that at the deepest level, reality is not a frozen sculpture, but a living improvisation. Each particle, each atom participates in the cosmic symphony, guided not by absolute command, but by probabilities, a graceful balance between order and surprise. And so, the same uncertainty that limits our knowledge also sustains our existence. It is the openness that keeps the universe alive. For ancient civilizations, the cosmos was explained through myth stories that gave the universe meaning and morality. Today, we tell our stories through equations, data, and telescopes. But they serve a similar role. The Big Bang is a new genesis. The quantum vacuum is a new version of the primeval ocean. Dark matter is the modern unseen realm, and the physicist, much like the poet, seeks coherence in mystery. Our myths have evolved, but their purpose remains to help us feel at home in an infinite universe, to remind us that we belong to something far greater yet intimately connected to it. Science and mythology differ in method, not in longing. Both are ways of asking, who are we and how did we come to be? When science reaches the limits of its language, poetry begins. When poetry seeks grounding in truth, science answers. Between them we find balance, logic, and wonder, intertwined intellect and reverence holding hands. Knowing that we are made of stars changes how we see ourselves and how we treat the world around us. Cosmic understanding is not only scientific, it is moral. If every atom in your body once belonged to something vast, if every breath participates in the evolution of the universe, then no life is isolated, no moment trivial. We are threads in the same tapestry of being. From that awareness arises humility, not the smallness of insignificance, but the grace of belonging. The same forces that sculpt galaxies also shape the curves of your heartbeat. The same balance that governs cosmic expansion sustains the breath between thoughts. To live with that awareness is to live gently, to recognize that existence itself is fragile and sacred. That every form of being, from starlight to soil, is part of the same unfolding. In that understanding, science becomes not just a study of matter, but a practice of reverence. To observe the cosmos is to honor it. To learn from it is to love it. The more we understand the cosmos, the more it mirrors us. Patterns of neural networks resemble patterns of galaxies. The distribution of matter echoes the distribution of thought clusters of energy connected by invisible pathways. Perhaps this similarity is coincidence, or perhaps it points to something fundamental, that complexity, whether mental or cosmic, follows the same universal logic. Some philosophers suggest that the universe is participatory, that observation itself shapes reality, as quantum theory hints. The act of perceiving collapses possibility into presence, transforming wave into particle, uncertainty into form. If so, the universe requires witnesses to be complete. It needs awareness to finish the act of creation. In that sense, mind and cosmos are one continuous feedback loop, the universe observing itself through living beings, and those beings discovering themselves through the universe. Every time you look up at the stars are also looking back through you. By now, the word nothing feels different than when we began. It is no longer a void, but a presence, the quiet condition for all that is. Science reveals it as quantum potential. Philosophy sees it as the fertile ground of being. both find the same truth that everything emerges from what cannot be named. The Big Bang, then, is not the creation of something from nothing, but the unfolding of what was always there, potential becoming form, silence becoming sound. And perhaps the journey of knowledge, too, follows that pattern. Every discovery is a small emergence from not knowing. Every realization is a ripple through the quiet sea of ignorance. Every act of understanding is a birth from nothing into something, a miniature Big Bang of awareness. We are each of us tiny expansions of that same cosmic motion. Every thought is a new universe briefly born within the mind. Time, like space, can be imagined as infinite. But when seen through awareness, all of it converges into this single moment, the eternal now. Every star that shines, every atom that moves, every breath that forms a question happens here, now. The past is memory, the future anticipation. Both exist within the present, a point of consciousness wide enough to contain all time. In this light, the Big Bang never ended. It is happening still everywhere, as the unfolding of now. Each instant is a continuation of that first expansion, the birth of the universe expressed again and again in galaxies, in trees, in thoughts, in you. To live is to participate in that eternal unfolding. To breathe is to echo the expansion of space. To sleep is to drift back toward the quiet stillness from which all things arise. Knowledge has boundaries, but wonder does not. The closer we come to explaining the universe, the more mysterious it becomes. Every answer reveals a deeper layer of unknowing, like galaxies beyond galaxies receding endlessly into the night. Perhaps that is the true lesson of cosmology, that the universe is not a problem to be solved, but a relationship to be experienced. That understanding is not an endpoint, but a form of intimacy. That awe is itself a kind of knowledge, one that speaks not through words, but through silence. And so, as the mind contemplates the cosmos contemplates itself. Science becomes meditation. Philosophy becomes quiet prayer. The observer and the observed dissolve into a single field of awareness, expanding forever. The universe continues calm and luminous, with or without our understanding, and perhaps that is enough. Silence returns vast and gentle. After all the motion, all the light, all the questioning, the cosmos folds back into stillness, not an ending, but a pause. The universe, having told its story through expansion and evolution, through atoms and awareness, now breathes quietly through every point of space, through every life that listens. We began with a question: what existed before the Big Bang? We wandered through philosophy and physics, through vacuums and fields, through time and thought, tracing the idea of nothing until it glowed with presence. And now, at the edge of this long reflection, the question feels softer. It no longer demands an answer. It becomes a form of wonder. Perhaps nothing never was. Perhaps the absence we imagine is simply another face of fullness, the universe before it realized it was alive. Perhaps before the Big Bang is not a moment in time, but a state of quiet being, the stillness that precedes every beginning and follows every end. In this calm, we begin to see that the story of everything is also the story of nothing, that both are woven from the same luminous thread. Across every stage of our exploration, one truth has remained constant. There is no boundary between the void and creation. They interpenetrate endlessly. The Big Bang was not the instant when something replaced nothing. It was the moment when potential revealed itself as form. Energy became matter. Stillness became motion. Silence began to sing. That process continues even now. Every second, virtual particles appear and vanish in the vacuum. Matter collapses into stars. Stars collapse into light, and light crosses the dark to become thought in a distant mind. Creation is not a single act, but a rhythm, an oscillation between presence and possibility. We live within that rhythm. Every heartbeat, every breath, every sunrise is part of it. We are not outside the universe observing its story. We are the continuation of that story. From nothing to everything, and from everything back to nothing. This is the pulse of existence. A movement without beginning or end. The cosmos is often imagined as a place, a container filled with stars and space. But perhaps it is not a place at all. Perhaps it is a living continuum where each part flows into every other, where even emptiness participates in being. The vacuum between galaxies, cold and vast, is not dead. It vibrates with energy, invisible yet real. It connects every particle to every other across unimaginable distances. Even in the silence between stars, there is communication. Gravity whispering photons, gliding space curving gently around mass. And within that continuum, there are no true separations. Galaxies are not islands, but eddies in a greater stream. Planets are ripples. Minds are moments of awareness within the flow. When we look at the universe this way, the idea of nothing dissolves completely. There is only movement, only change, only transformation. The dark between things is not a void, but a field of relation. We exist as part of that relation, neither apart nor above, but within. The cosmos breathes through us, and we breathe it back. Imagine tracing the timeline of the universe backward through galaxies, through atoms, through the first light, until all matter converges. At that limit, time folds, and the universe curves back on itself. The question, what came before, becomes, what continues through. The cosmos is circular, not linear. Each stage flows into the next, and every end feeds a new beginning. Stars die and scatter their elements, seeding new stars. Black holes consume and radiate, shaping the galaxies that orbit them. Even entropy, that slow drift toward disorder, is balanced by the emergence of new forms, order, arising from the very process that dissolves it. Creation is cyclical. Every collapse contains expansion. Every stillness hides a motion too slow to see. And in this unbroken circle, nothing becomes a necessary phase, the moment of rest between the breaths of infinity. The Big Bang was one such breath. But perhaps there have been others, and will be more, each a renewal of the same cosmic pulse. Somewhere along this continuum of transformation, matter began to perceive itself. Atoms became molecules, molecules became cells, and cells became consciousness. Through this slow evolution, the universe learned to look back at its own reflection. When you gaze at the stars, you are that reflection. awareness shaped by 13.8 billion years of unfolding. You are the universe observing itself through the eyes it built from its own dust. That realization changes everything. It means that consciousness is not separate from the cosmos, but continuous with it. It is not something the universe contains. It is something the universe does. Awareness is the flowering of matter, the shimmer of the quantum fields arranged into perception. Through it, the infinite experiences itself in finite form. Even the act of asking what came before the Big Bang is a manifestation of that cosmic self-awareness. The question arises within the universe as the universe. The cosmos contemplates its own origin not from outside but from within. We are the wondering of the world. Light, too, carries memory. Every photon that travels through the void remembers where it began, from the first fire of creation to the flame of a candle in your hand. It connects time, space, and thought into a single continuum. In the beginning, light was the universe itself, dense, trapped, seeking release. As the cosmos expanded, that light cooled, spread, and formed atoms. Eventually, it illuminated the first stars. Now that same light touches the surface of Earth, enters your eyes, and becomes vision. It crosses from the outer to the inner, from the physical to the perceptual. The same photon that once scattered from the dawn of the cosmos may now shimmer upon your retina as you look into the night sky. So the universe speaks to itself in light, a dialogue between its own beginnings and its awareness. The CMB hums softly through every direction, the faint background whisper of everything that was still echoing in everything that is. And in that hum, every particle of you listens unconsciously, remembering. The grandeur of cosmology can make daily life seem small, yet the opposite is true. Every quiet moment mirrors the structure of the universe. Every small cycle reflects the vast one. The rising and setting of the sun, the ebb and flow of tides, the beating of a heart, all echo the same cosmic rhythm. Energy condenses, releases, renews. Creation and dissolution alternate endlessly. When you breathe, you enact the Big Bang on a smaller scale. Inhalation, expanding space within your chest. Exhalation, returning it to stillness. When you sleep, consciousness contracts into quiet potential, then expands again at waking. Even thoughts arise and dissolve like galaxies, forming and fading in the dark matter of the mind. The universe is not distant. It is intimate. It lives through every pulse of being, through every moment of attention. The infinite hides within the ordinary, waiting for awareness to find it. So when you feel small beneath the stars, remember you are not beneath them, but part of them. You are not separate from the cosmos. You are its continuation in another form. We often imagine science and mystery as opposites, but they are not. They are partners intertwined like matter and space. Science describes how the universe behaves. Mystery reminds us that it is. Every equation is a line of poetry written in the language of precision. Every experiment is a kind of devotion, a way of listening more carefully to the song the universe sings. And every unanswered question is a pause in that song, a moment of silence that gives shape to the melody. The Big Bang quantum fields. Dark energy, all are verses in this cosmic composition. And when we listen closely, we realize that knowledge and awe are not two paths but one. To understand is to revere. To measure is to marvel. The laws of nature do not diminish wonder, they deepen it. They reveal that order and beauty are not separate, that reason and reverence are reflections of the same truth, that the universe is both intelligible and ineffable, both describable and mysterious, both finite and infinite. Every story ends where it began in silence. The Big Bang began in silence, and into silence it will one day fade. The stars will burn out. Galaxies will drift apart. The last photons will stretch into invisibility. And yet even then the quiet will not be empty. It will still hum with quantum potential, the same potential that began everything. The universe will not die. It will rest. It will sleep within itself, waiting for the next rhythm, the next pulse, the next transformation of being. We mirror that cycle too. Each night, the mind withdraws from form into formlessness. Each sleep is a small death, each waking a small rebirth. We dissolve into stillness and rise again, unaware that we enact the cosmic process every day. So when you sleep tonight, imagine the universe doing the same. Its galaxies slowing its fields, softening its energy, quieting into rest. And in that stillness, something new already begins to stir. Perhaps the deepest realization that comes from all this is not scientific, but human, that to exist is to share in the same origin, the same unfolding. Every being, every atom, every thought is part of one continuous event, the expansion of the universe. We are all expressions of the same moment, different faces of one infinite breath. From that awareness arises compassion, not as morality, but as recognition. To harm another is to harm a part of the same whole. To care for another is to care for the universe itself. The cosmos does not separate, it unites. It invites empathy by revealing that there is no other, only self in many forms. Even the void between us is not empty. It is filled with light that has simply traveled too far for the eye to see. When we realize this, love becomes cosmology. Connection becomes the first principle. The Big Bang becomes not an explosion, but a blossoming, an outpouring of relationship, expanding still. We have spoken of nothing as vacuum, as potential as silence. But what does it mean finally to say that there was nothing before the Big Bang? Maybe nothing is not the absence of existence, but the absence of distinction. Before space and time, before particle and field, there were no separations, only unity. No this, no that, no here, no there, only wholeness beyond measure. From that undifferentiated stillness, contrast arose, expansion and contraction, light and dark, question and answer. The universe began not by gaining something, but by dividing itself into opposites that could reflect each other. To say there was nothing is to speak of a time before contrast, before the mirror of duality. It was the moment before the first difference, the calm before the first note. And so perhaps nothingness is not the void we fear, but the completeness we forget, the fullness so whole that it contains no separation at all. Every field, every fluctuation, every quantum breath of energy points toward a profound idea. The universe is self-creating. It does not emerge from outside itself, for there is no outside. It arises from its own potential, as a flower arises from soil, as thought arises from mind. It is both the cause and the effect, the question and the answer, the beginning and the continuation. This is the quiet elegance of existence, a cosmos that needs no external maker because it makes itself continually from its own essence. It is neither random nor imposed, but natural, the inevitable unfolding of possibility into form. In that realization lies peace. The universe does not require justification. It simply is. And its being vast and silent is enough. Now the journey returns to its beginning. We have traveled from philosophy to physics, from vacuum to consciousness, from nothing to everything. But perhaps the two are not opposites after all. Perhaps they are the same reality seen from different sides of perception. Nothingness, in its truest sense, is not absence, it is potential. Everything, in its fullest sense, is not completion, it is the expression of that potential. From nothing comes everything. From everything, nothing returns. It is a continuous exchange, a cosmic breathing that never stops. And you listening, thinking, dreaming are part of that motion. You are the meeting point between nothing and everything, between silence and sound. You are the universe remembering itself and forgetting again with each breath. You have traveled far tonight across the long expanse of time, through the shimmer of galaxies and the whisper of quantum fields. You have followed the universe from its first tremor of potential to its quiet present, where stars turn slowly in the dark. Now return to stillness. Let the cosmos rest within you as it rests within itself. The same atoms that burn in distant suns drift in your breath. The same energy that once lit the first moment hums softly in your heart. The universe continues vast, patient, eternal, and you are its continuation, calm and luminous. Close your eyes. Let your thoughts dissolve into the quiet field from which they came. Even now, space expands gently around you, carrying galaxies outward like petals on an endless tide. And within that motion, there is peace. The universe needs no beginning to be beautiful, no end to be complete. It simply is breathing through the silence, glowing softly through the dark. If you are still awake, listen to the hum of the stars. Otherwise, let go. Let the question fade. Let the night hold you and sleep as the universe sleeps, in calm, in endlessness, in light. The night deepens. The stars turn slowly like thoughts drifting across an ancient mind. Somewhere, galaxies spiral in silence. Somewhere, light crosses the dark between worlds. And here, within this single moment, the universe pauses, breathing through you, through everything. There is no boundary now between what is vast and what is near. The same stillness that fills the spaces between galaxies fills the quiet of your chest. The same rhythm that moves the tides of time moves the rise and fall of breath. The cosmos is not outside you. It is within you, murmuring softly through every atom that has ever been alive. You do not need to hold its history or remember its measure. You are already part of it, an unfolding within, and unfolding a note within a chord that has no end. The beginning was never elsewhere. It has always been here, flowing gently through this eternal present. So let go. Let the great questions fade into stillness. Let the mind loosen its orbit and drift weightless among the stars. The search can rest. Now it has found its quiet answer in the sound of its own breathing. Even as you sleep, the galaxies continue their slow turning. Even as you dream, light still travels from one horizon to another. You are carried in that motion, peaceful, infinite, at ease. Beneath thought, there is only the hum, the low, steady vibration that underlies all being. It is the same sound that filled the first moment, the same that will echo through the last. Listen, and you may feel it, a warmth in the silence, a gentle presence in the dark. It does not speak yet. It says everything, that all is well, that all has always been. The universe rests now, and so may you. Drift into its calm. Let the stars watch over you as they have watched over everything. The great unfolding continues endlessly, quietly, beautifully. Sleep now. The cosmos holds you. The night is infinite. And it is enough.